in one of our design sessions, I had talked about polymorphism and presented some sort of use cases for when we might use it in order to make our code a little bit more type safe and kind of separate out uh, behavior that's very specific to different types. We kind of presented that in the context of these ever expanding if statements, but I kind of fumbled through the explanation of how you would actually implement this, especially well and in our DMS server project. So I wanted to make this follow-up video to describe how to do that step by step, all the way from kind of encountering a problem which might benefit from it to sort of a final solution that would actually work well and kind of adhere to the principles that this project adheres to itself. So for our example, this is a financial statement. I'm not going to get too much into the details of financial statements, but we're going to have to support a number of different financial statements and probably going to have to support different versions. They tend to come out with updates yearly, so not all of them, but some of them. But the gist of it is we have code that can, in a very general way, produce values that will fill in the boxes on these financial statements. So for example, on the screen we're looking at, these values in the amount columns are generated by our code. However, we recently ran into an issue where some specific boxes, specifically this one right here, this 101, negative 101, and the 0 here, these needed special treatment. So product had asked us basically to flip the sign. So in this case, we have a negative 101. That should be a positive 101 and vice versa. This is a little bit unfortunate because while most of the code has been written in a very general way that can accommodate any financial statements, now we specifically have had this request for this particular financial statement on this particular version to have these two boxes have sort of a special case behavior. Now we went ahead and solved this via essentially a data fix, something that we did in the database. There are problems with that solution. It might be ideal, especially if it's a one-off type of thing, but if we see more of these requests, then we may need to come up with a better solution that makes it maybe more a little bit explicit what we're doing. So I had an idea about how we might go about doing that. I'm not saying that this is the solution, but this is also a good instance where we can demonstrate how you might use polymorphism to solve this problem in a way that doesn't destroy the existing code and kind of makes more explicit what's going on. So the premise here is have many financial statements, many versions of financial statements, and each of them has hundreds or thousands of these values, but we might need to have special cases. And in fact, after speaking with product and everything, this is actually not an unlikely scenario. So we'll go ahead and take this as our starting point. And the gist of it, again, is just that we need to negate a couple of values out of all of these thousands of values on potentially multiple different financial statement sheets. So again, the goal here is to find some place in our C# code, or potentially the front end. In this case, we're going to look at the C# code, where we can make this adjustment to these values as they're processed. So we have a file that looks like a good place to start here called process financial statement values command. And what this does is it gets all of the values that we saw in the previous, in the PDF that we just had up, and it processes them in a very generic way. And this execute function looks like it might be a decent place to stick that code that will modify values as they come through. So for example, we could here, this again, this is just for examples, so we're not going to get too much into the details of exactly where it might go, but I've gone ahead and prepared some code to show kind of what that might look like. Okay, so I've just inserted the code here between these two comments. You could potentially factor this out into a different function, but we're going to look at like why this code could be problematic. you can see straight away we have some if statements, and what we're taking into account here is the financial statement type. So for example, we might have a forward financial statement or an NIADA statement, sometimes called independent, which is what we just saw on the previous screen. And then we might have some code here. In this case, I have it commented out, but we may want to check to see which version we're working with. And then we might want to specify the specific report identifiers that we want to modify and have the actual modification for those report identifiers in here. But the problem here is that most of this code, as mentioned, works with all financial statements. It's very general code, which is great. And as programmers, we want to write code that way. Unfortunately, it's kind of impossible in this scenario because we have a very specific requirement that can't be generalized. So we have these if statements stuck in the middle of our otherwise pretty nice function. And we can see that as we get more and more financial statements, more and more versions of these financial statements, and more requests from product or the customers or whoever to add special case behavior, this if statement is going to continue to grow kind of indefinitely. And even if we have this factored out into another function, that's still going to be a problem. And this same type of if statement, very often in these cases, I don't know about the specific case, but you'll have the same sort of if statements replicated throughout the program. So we might have in a different command or query object or somewhere else logic that ends up branching based on the report type. So we want to see if there's maybe a better way to handle this. And as discussed in the design session, well, we could replace this with polymorphism. In this video, we're going to talk about exactly how you would do that. So as a first step, we're going to go ahead and take these if statements and we're going to convert them into objects, and then we're going to see how that kind of changes the way that this code looks, why just pulling objects out isn't necessarily the immediate end solution, and what we can do about the problems that crop up once we've done that. The first thing I want to do is take a look at each of these if statements to kind of see what's going on here and how we might create a class structure that makes sense. We have if statements here that are broken up based on the type of financial statement as well as a potential version. So what I've gone ahead and done is made a couple classes you can see over here on the right: financial statement NI88 2023, and the same thing for financial statement forward 2023. And the idea is we're going to take each of these branches and we're kind of going to port that behavior over into these classes. We also want to have an interface so that we can treat each of these financial statements in a generic way, and each of the classes are going to implement code that will do their specific report identifier processing. And I've gone ahead and made these classes ahead of time. We're going to take a look real quick at what they look like, in particular for the independent one, which I fleshed out a little bit more. If we click on our financial statement NI88 2023 file, we can see that we have the same bit of code. We've gone ahead and just copy and pasted this from our command object into our class, and we've just gone ahead and made a function in our class which makes sense for what's happening here. So in this case, we've called it process report identifiers, and we pass it the report identifiers. We can go ahead and take out the part of the if statement which deals with the type of report, which in this are the type of financial statement, which in this case we already know is an NI88 2023. We'll deal with that logic here in a moment, but as a first step, we want to just see how we can move that logic into its own classes. We retain the if statements here, which branch based on report identifier. We could potentially have more special case identifiers after this, but that's basically the gist of it. This get financial statement type function, we'll talk about this a little bit later. I've intentionally left that in here with an error, but I don't want to complicate things too much out of the gate. Likewise, for our forward financial statement, we made another class, financial statement forward 2023, and you would end up just taking this logic here, and in the same way, I haven't really fleshed it out here just due to time, but you would have that logic ported over into this function as well. And then, like I said, both of these classes would implement a financial statement interface, which defines the functions that all of the financial statements will need to conform to. So now that we've written our two classes and we moved our behavior, or at least copied our behavior into them, all we need to do is instantiate them in whichever part of the code that we're going to use them. So here we've moved the if statement, or at least for now we're going to copy this if statement out of this for each section and use it to instead instantiate the objects, which will then be responsible for doing the actual processing. So in this case, we have an if statement for what the report type. If it's independent, we'll go ahead and instantiate our NI80A object. We'll probably also take the year into account at some point, and assign it to a financial statement variable, which this variable itself doesn't really know anything about the object. It's the interface. Then in our for each loop down here, where we have all of the logic, we can go ahead and replace everything in here with just our financial statement function call. So a process report identifiers and pass it the parameters that it wants. And you can even make this a little bit more brief if you'd like. And so this looks a little bit more compact. And now we're able to use this class polymorphically to process report identifiers, but in truth, we haven't really eliminated completely our initial problem, which was that we wanted this function to not really have specific behavior. We kind of cut down on the complexity here by moving all of the specific processing behavior into its own classes, which is nice, but that's not really too much better, right? I mean, we could have just factored those out into a different class and not really even use polymorphism. We're still retaining this if statement. So we need to look at how to get rid of that. Luckily, this is a very common problem with a very common solution, and the solution is actually pretty straightforward. We're just going to go ahead and make another class, but this class is going to be what we call a factory class, which is responsible for handling the creation of objects. And once you move this if statement out of this class, we're going to see that we no longer have this class burdened by behavior specific stuff, and that's going to be sort of the major step. It's not really the final piece of the puzzle. We'll get to that in a moment, but that's definitely going to get us a lot closer. So what I'm going to do is I'm going to go ahead and write factory classes and show what it looks like with those factory classes implemented, and then how we can set that up in this class in order to get us back to that more generic state. Okay, so I've gone ahead and created a file called Financial Statement Factory. I've also created an interface for it just so that we can use our dependency injection framework. And I've moved the code, or at least copied the code from our original command. So this is just checking the report type and year, creating the object, and then returning it through our iFinancial Statement interface. So if we go back to our original file, we can see that the same set of if statements are right here. These are now in our factory class, so we no longer need these, and instead we can use our factory right here. I've also gone ahead and written the code to do our typical dependency injection thing. So we have our interface, our iFinancial Statement Factory here added to the constructor, which will go ahead and inject our factory. I have the private read-only variable up here, and the assignment just as you've probably done 1,000 times already. If we move down here, instead of having the if statement, which is now in the factory, we can just set this financial statement variable directly using our factory. So financial statement factory dot create, and then we'll go ahead and pass it the report type and the year, which in this case, we'll just stick at it. Ordinarily, we'd have code that would pull up the year or handle the version however you wanted to. This is, of course, just for the sake of argument. But at this point, we have now successfully pulled all of the if statements out of this function, and we can see that this works in a very generic fashion. We just get our financial statement type, create whichever financial statement object will handle that, which is handled by our factory, and then we process our report identifiers in whatever way that financial statement object works. But this class, as far as it is concerned, it no longer really knows about any specific financial statement factories. our financial statement classes. One thing I did want to point out is in our financial statement factory, the reason that we end up having to make this is because the reality is our factories are going to need to be instantiated at runtime based on values that we pull out of a database or from an API. One thing that we can't get around here is if we are passed a value that we do not know how to handle, we just have to throw a runtime exception. This is polymorphism is called runtime polymorphism because it happens at runtime. If we get a type that our factory doesn't understand, then we just end up having to throw an exception. So this is a pretty common thing. Also, one of the things that we do a lot in our code base is we try to code everything against interfaces. And we've managed to do that in the process financial statement value class here, since we only rely on the interface for the financial statement factory as well as the interface for the financial statement. So that's great. But our factory is it's like our sacrificial class, right? In this case, we rely directly on the concrete financial statement, excuse me, classes. But this is just it. This is our way of sort of containing all of this kind of nasty, this if statement initialization. This is where it ends up going. And that's an important thing to understand as we move into the next complication, which is going to be the final step. And something that isn't super easy to express in a demo, but I'll try just using some sort of theoretical example to show kind of a problem that can occur here whenever we're instantiating objects, and a way that we can solve the problem with an understanding that this factory class is sort of where we are lumping and containing the ugly code. But I hope you can see already that we're in a much better situation because our original command object is still very generic, and if they ask us to add in new financial reports or whatever, this doesn't really need to change. It's still a very generic function, and instead we can just update our factory and then add a couple new classes here in the financial statement folder, and we're good to go. We don't even have to touch the existing command, and that's really kind of the beauty of polymorphism. So if you've made it this far, kind of like holding on to what I'm saying here, then the next part of it, even if it gets a little bit complicated, is something that, we can cross that bridge when we get there. So just make sure that at least you understand what's going on up until this point, and be sure to ask questions if you don't. So the final issue that I really want to talk about here was a kind of a hidden one that whenever you implement this in practice, you're going to inevitably run into. We create each of these objects here, and while we know that the factory class is kind of our dependency magnet, it's where we're putting the gross code, there's kind of an annoying problem that tends to come up, which is that in this toy example, which, this is what this is, I'm not actually implementing this in the code base, it's just an example of how you might go about doing it. But these financial statement objects don't actually take anything. So it's very easy to instantiate them, right? In the constructor, we're not passing them any values. But in practice, this might not be the case. And whenever we have to pass values to constructors, sometimes those rely on other objects to be instantiated first. And it can be a real pain to instantiate everything. So we have dependency injection frameworks that take care of this for us. So as an example, just to kind of illustrate, I want to quickly fill in some parameters here just to show you what that might end up looking like, although they're all going to be made up as this is a toy example, but hopefully just to show you kind of what it is that I'm talking about. Okay, so here, just as an example, I've updated this financial statement in I-88 2023 to take a TransactionTranslator object. Really doesn't make any sense in this context, but just suppose that this class, now has something in the constructor that it needs. And remember, some of these classes could have many objects in the constructor, 5, 10, whatever it is. We need to instantiate a transaction translator just to create the financial statement and IDA class. So if we come up here, we create a new transaction translator. But of course, this needs various objects as well. And then, we instantiate each of these, and this can potentially become very cumbersome. So how do we solve this issue? Well, we can rely on our dependency injection framework in a way that's not usually advised, but I think in this context and from what I've read online, actually makes a lot of sense. And I'll show you how that is done. So what I've done here is I've added a sort of a dependency here called iKernel, and this will inject the kernel dependency, which is our way for us to kind of directly access our dependency injection container. And using this, we can instantiate this translator directly. So we can go ahead and get rid of all of these lines as well as the new statement, and instead we can use our kernel. Go ahead and get the service of our transaction translator, and this will give us the transaction translator without having to worry about wiring up the object, and then we can just easily pass that into our statement. Now normally you shouldn't do this. You shouldn't use the dependency injection framework directly, because this ends up tying this class to our dependency injection container. But again, since this factory is meant to kind of contain all of the ugly parts of it, and there really isn't any other way around it other than, you know, the manually instantiating everything, which is the, you know, it defeats the point of having a dependency injection container. So we'll go ahead and use the kernel object in here and just accept that this is going to be the ugly class. And if we ever were to switch our dependency injection framework, we would know that we have to come through and update these factory classes. But overall, in order to get this sort of polymorphic behavior, I think this is generally a win. So in my opinion, this is definitely something that we should try to do, but it's not strictly necessary in order to get this working. So I know this seems like a bunch of steps. We had an if statement, which, even though I discussed the problems with it, which I think are pretty serious, we took what was a pretty simple if statement and then blew it up into a much more complicated thing. So I wanted to kind of reiterate, although I mentioned it in the video, but here at the end I wanted to reiterate what the advantages of this method are. Remember, this was to address the issue of sort of forever growing if statement, which has a lot of special cases in it. If, for instance, we had another financial statement from Hyundai or, you know, some other manufacturer, whatever it ended up being, the win here is that this process financial statement values command is actually, you know, we don't even need to touch this, right? What we would end up doing is we would create a new object in our folder, which would be financial statement Hyundai or whatever it is, and we would update the factory class, right? This is the one that we would have to update to say, okay, well, you know, if we have report type of Hyundai and it's 2023 or whatever, go ahead and instantiate that object. And then whenever we actually write our class, we'll just implement the financial statement interface, and that'll automatically tell us what functions we need to implement in order to get this working in our program. And after we've done that, remember, we haven't touched the actual process command. We've just added a class, we've implemented the interface, and then updated our factory. And after we've done that, everything will just automatically work. So the idea here is we can write code that's very general, and once that's in place and it's debugged and working, we never have to touch that code again. And instead, we can just add in these extra classes, update our factory, which we know is gross, and it's also, you know, when you look at it, it's really not all that complicated, right? I mean, the factory is just, it's a very simple if statement. It's all in place. So we update the if statement, write our new classes, fill in the blanks, right? The interface is going to tell us which functions we need. In this case, we just have the one, but if this had, you know, 5 different functions, we would know exactly which ones to implement. We would have some very clear-cut examples of how you know, the other reports had done it, and it just makes it very, very much like explicit what's going on. We're processing the report identifiers. This is where we put all that special case code, and it's not a mystery. The way we ended up solving this particular problem was to create in the database a fake report identifier and then multiply it by -1. There's no comments, there's no, you know, naming conventions that would tell somebody who hadn't seen it before what's going on. So it's all very much a mystery, and it's knowledge that's going to be lost probably, you know, within a month or two. Even the people that worked on it are probably not going to remember doing it or why they did it. But if we encode things instead this way, it's much more clear what's going on, and we don't actually destroy our generalized code. There are a bunch of other situations where this is useful. I had implemented it in the 1099 forms via this default values creator, which is very similar to this one, where we end up needing to pull values in a specific way based on specific forms and specific versions of those forms. There's another opportunity on 1099s. We have a bunch of places where we're, excuse me, where we're actually, we have if statements based on the type of the form. And if ever we need to introduce new forms, we're going to have to come through and we're going to have to update these if statements. I had an example pulled up here earlier. Let me see. Something like this could be also encoded polymorphically. Whether or not we want to there or not is up for debate. Power posting, there's a lot of opportunity there. We have a bunch of different templates, and we might need to do, or in fact, we definitely will need to do special case type things based on each particular template. And so that's another possibility. And I'm not saying, obviously we can see that there is some overhead in that we blow, an if statement up into multiple files, have a couple of interfaces, got this factory, we're using this weird kernel thing, right? It's not an automatic win, but as programmers, we strive to write general code. And whenever we have we have a need, which does exist, to write special case code. This is the mechanism that's built into these languages, and this is something that is in all languages, right? These days, right? In modern day languages, pretty much always exists an object system that allows you to do this, and even in languages that don't have object systems, like pure functional languages, we have algebraic data types, which is beyond the scope of this video, but they have a solution there too, because it's a very common problem, and we need solutions that will work well and reliably and just kind of be, for lack of a better term, idiot proof, right? Anybody who comes in here years down the line in this like made up example and they're like, oh, we need another special case for financial statements, they can just look at these interfaces, say, oh, let me just implement this interface in a new class, and then I'm done, right? Update the factory, you're done. And so it's definitely a bit more effort, but in cases where it's going to be needed because you're writing gross code, it's something that you should at least toy with, maybe talk about with other devs and figure out if that's the way to go or not. If it's going to be more trouble than it's worth or what. But definitely fundamental thing that's taught to everybody, and then I've literally never seen it used in any code base that I've ever worked on professionally. So I wanted to go ahead and just show how this is done sort of from start to finish, and then see if we can't make use of it.